Assalamualaikum and good morning. Today, me and my team, I would like to present to you about a website that we made. It's about differentiation in food security, modeling sugar crystallization rates. First of all, my name is Arif Iqbal bin Afendi, number metric F24A 1288. Today, so let me present to you about my website. So this is it. As you can see, it's about modeling sugar crystallization rates. So here's a simulation about calculus in food security sugar crystallization. It says that this interactive simulation demonstrates how differential calculus model sugars grow crystal growth, a crucial process in food production and security. So let me show you an example. So we just adjust this, the super saturation, like for example 1 gram per milliliter, and for the growth rate constant we just put a random like 0.05 millimeter, and the temperature I will choose 40 degrees Celsius. So uh, it will be like this. Yeah, as you can see, it will be like that. So the next one, so we just press you. So the next one I will show about the video related to crystallization.
Hey, what if I told you calculus could literally make your dessert sweeter? Today, I'm diving into a real world mystery. How fast does sugar crystallize out of syrup? And what does that have to do with food security? Let's say you're in charge of making rock candy. You mix up a supersaturated sugar solution, but here's the kicker. How fast do those sweet crystals actually form? That's where differentiation comes to the rescue. Imagine the mass of sugar crystals, let's call it MT, growing over time, ET. The rate at which crystals form is dm/dt. That's the derivative. Chemists found this rate actually depends on how much sugar is still left to crystallize. The classic model looks like this: dm/dt equals sign Ka(m), where m is the mass of crystals at time t, a is the total possible mass of crystals. K is a constant describing how quickly those crystals want to form. This is called a first-order differential equation. It's like the sugar is racing to the finish line, but the closer it gets, the slower it goes, just like you finishing a marathon on zero sleep. So why does this matter for food security? Well, industries need to control crystallization rates to store sugar safely and prevent spoilage. Too fast, and you get clumps. Too slow, and the sugar can go bad. Calculus helps you model and optimize the sweet spot. So next time you stir sugar into your coffee, remember, you're harnessing the power of calculus, just like scientists and engineers. Drop a comment about your favorite math in food moment, and don't forget to subscribe for more delicious learning.
Okay, then this is for the podcast video. It is too long, so I just play a
Okay,
little bit.
let's get started. Welcome to the deep dive. Today, we're doing a deep dive into something, well, maybe a bit unexpected. We're connecting mathematics, like the abstract stuff, with food security. Really practical.
Yeah, it's a fascinating link. We're looking at this piece. It's titled Food Security Differentiation, Modeling Sugar Crystallization.
Mm,
Kind of gives the game away right there in the title, doesn't
it
it?
really does. And our mission, really, is to show you how the math you might be learning right now.
Mm.
Think
All right, so this is too long, so I just show a little bit. So the last one will be the questions about sugar crystallization. So there are 5 questions here, so that people can jawab, and then just submit the answers, and you will get how many do you get right. So that's all for my website. Thank you. Ajwat, please present your website.
Alright, so moving on, it's my turn. My name is Muhammad Shahjat Meranan, metric number F24A1283. And now I will be presenting my website. Alright, wait a minute. Wait a minute. Alright, and so here, this is my website. The same with Iqbal. My website title is Differentiation in Food Security, Modeling Sugar Crystallization Rate. So here is the animation for my website. Mathematics of Sugar Crystallization. Uh, Contrary to Iqbal, my adjustment button is at the side while the animation is here. Alright, so it's quite similar to the Iqbal website. We just have to adjust here. Alright, so I will just randomly put value here and here. Right. So let's see if it works. Alright, and so here is the animation for my website. Right. Alright, here we can see the result of the animation for the given data. Right. So moving on to the next part is the video about the modeling sugar crystallization rate.
All right, imagine you're in a candy lab, trying to make the perfect sugar crystals, just like that rock candy you loved as a kid. But here's a twist in food security. It's not just about making treats, it's about understanding how sugar crystallizes to preserve food and keep it safe for millions. And guess what helps us model all that? Good old calculus. Let's break this down. When sugar dissolves in hot water and then cools, it starts to crystallize out. The rate at which sugar crystals form depends on a bunch of stuff: temperature, concentration, even how much you stir. Mathematically, we can model the mass of sugar crystals, let's call it MT, over time T, the rate of crystallization. That's dm/dt, a fancy way of saying how fast are those crystals forming right now. Here's a simple formulation: dm/dd equals sign K Cs Ct, where K is a constant based on conditions. Cs is the saturation concentration, how much sugar the solution can hold, and Ct is how much is actually dissolved at time t. If Ct is way less than Cs, crystals appear fast. As it gets closer, things slow down. Now, integration lets us predict, given the starting concentration, how much sugar will crystallize after, say, 5 minutes. This isn't just sweet talk. It's how industrial food engineers design safer foods and avoid spoilage. So next time you drop sugar in your tea, remember, you're not just making it sweet, you're living out a real-world math problem that keeps the world fed. Differentiation and integration, turning sugar, science, and security into one tasty equation. Stay curious and keep letting math add flavor to your life.
Alright, that's all for the video. Now moving on to the podcast. And since it's also quite long, so I will just play some of the intro.
Okay, let's unpack this. We're diving into something that might sound, well, deceptively simple, maybe even sweet. The math behind how sugar crystallizes.
And what's truly fascinating here, I think, is how this specific, seemingly small piece of physics and math, it connects directly to a much larger, absolutely crucial field, global food security.
Food security, really, from studying sugar crystals. Okay, that's
Yeah.
where it gets really interesting. And a bit surprising, honestly. Our source material digs into a very specific link here. It talks about using the mathematics of sugar crystallization,
Yeah.
and specifically the concept of differentiation to model the rate sugar forms crystals.
Exactly. Because
Alright, so that's all for the podcast. And here, for the final part, the quizzes. Differentiation in food security, sugar crystallization. So here we have 5 questions which anyone can try to answer in order to test their knowledge regarding this topic after going over all the other materials. So that's all for my website. Moving on to the next person, Hani.
My name is Nurhaniza binti Bakari. My ID number is F241000. So basically, my topic is same as them, modeling sugar crystallization rate. So this is my simulation. Sorry. So this is my simulation control. Simulation control can control the temperature, initial supersaturation, impurity level, and seed critical surface area. And it will display on crystallization process graph. Okay. So you guys can start the simulation and get the answer. And next, okay, next, this is my video and short podcast.
All right, picture this. You're eating your favorite candy, maybe a gummy bear or a sweet, crunchy snack. Ever wondered how sugar inside that candy goes from syrupy liquid to those perfect, satisfying crystals? Here's where math, and specifically differentiation, makes your food tastier and our food supply more secure. Let's break it down. In the food industry, controlling the rate at which sugar crystallizes is crucial. Too fast and you get clumps. Too slow and it's just goo. So how do factories get it just right? Enter the math hero, the rate equation. Scientists model the rate of sugar crystallization using a differential equation, dc dt equals sine k C's C. Let me explain. C is the concentration of sugar already crystallized. C's is the maximum possible concentration, and K is a constant that depends on temperature and stirring. dc dt basically means how fast is the sugar turning into crystals right now? Imagine you're in charge of a giant batch of syrup. You want as much sugar as possible to crystallize in the shortest time, but not so quickly that it messes up the texture. By tweaking temperature or how fast you stir, you're actually changing that K value. And thanks to differentiation, you can predict exactly how fast sugar will crystallize. Why does this matter for food security? Well, the more efficiently you can control sugar crystallization, the less food goes to waste and the more reliable the food supply becomes. That's math making a real-world impact, keeping your snacks crunchy and the world a little bit sweeter. So next time you enjoy a piece of candy, remember, there's a whole world of calculus behind that perfect bite. Math isn't just numbers, it's the secret ingredient to global food security.
Okay, in my podcast, tunjuk sikit lah.
Welcome to a deep dive.
Great to be here.
We've got a really interesting source today. It's an excerpt discussing differentiation in food security.
Right. Which, might sound like two totally separate worlds at first.
Exactly. But the specific thing our source highlights and what we want to unpack in this deep dive is this connection it makes to modeling sugar crystallization rates.
Yeah, specifically within that food security context.
So our mission really is to dig into that link the source points out. It's kind of surprising.
Definitely. And it shows how, let's say, sophisticated math pops up in places like food science. Unexpected relevance.
Okay, so let's unpack this a bit. The source doesn't just vaguely mention it, right? It draws a direct line. Differentiation in food security, leading straight to modeling sugar crystallization rates.
It's very specific, pinpointed, really.
And what's, I think, so powerful.
Okay, and the last one is my quiz. So you guys can answer the quiz. Alright, that's all. Thank you.
Okay, that's all from our team. Present our own uniqueness of the four element and about our own website. So if you have time, you can answer our questions in website given. So guys, thank you and bye.